So what I will show you now actually relates a little bit to what Elena would have shown. So in this, as you already saw in last sprint demo, I may even have some here. So I have here a trace file that I have generated for one of the samples, more or less. And here, yeah, there are some things that Elena will talk about, the things you see on the top here, the trace configuration and some timestamps that we now can capture. In addition to the previous information, we have this JSON object at the end. And these timestamps are useful for many reasons. First of all, let's talk about what they mean. So time to receive, that is the time when a message is received by a capsule instance. And by receive, we mean when the controller dispatches the message to it. And then time 3 handle, that is the time when the capsule instance has processed that message in its state machine. So the difference between these two timestamps is basically how long time did it take for the state machine to process that message. We have, as you may have remember, in last sprint, we supported, in addition to this format, we also supported another trace format, which was based on a web server on the internet called JS sequence diagrams, which was more for documentation purposes. But we have now realized that there are simply too many trace formats out there and too many ways how to use a trace. And it was not really feasible for us to support them all in our target RTS. So now we have taken a different approach, and that is to standardize on this format that you see here on the screen, the art trace format. And then we have open sourced the parser, which you can use for parsing these files and translate them into any other format that you may want or may need. And if you go to GitHub, there is this repository under HCL Tech software called Art Trace. Here we have placed the source code for this art trace parser. It's a single TypeScript file, traceparser.ts, which gives you one function that is exported and you can use called parseLine. And here you simply give a line, which is something you either read from an art trace file or maybe you have it in memory in some other way, and the line number. And then you get back an object that represents what is on that line. So this art trace syntax is a line by line trace syntax. So all declarations are written on a single line. They don't span more than one line. And if you look back here, you see we have instances starting with the instance keywords. Those are represented by an instance declaration object. We have message occurrences, which are these lines, where there is an arrow, a sender to a receiver, which is represented by a message occurrence. And then there is also, I think it's not shown here, but if you're pausing your trace in the middle, you get a note that tells you that the tracing is paused, and that is represented by this note object. And of course, that can also be a case of syntax errors, then you get a null back. So by calling this function, you can then get the representation of the trace file, and then you can translate that into whatever format you like or do whatever analysis you like with the trace files. So for convenience, we have also built an NPM package out of this API. So it's available here on NPM. So you can just start to use the art trace module directly from your TypeScripts or JavaScripts. And I will show you some of the samples that also are present in this GitHub repository. So here I have cloned that repository. And if you go under samples, you will see a few TypeScript files that show some examples what you can do with this API. And one, for example, is this JS sequence diagram. So this one, if you run this, it will produce the same format, the MS format, which is accepted by this JS sequence diagram that previously was supported by the target RTS itself. So we have now removed that from target RTS and instead provide this script that you can use if you want to have use that web service for visualizing your sequence diagrams. But there are also some others here, and they are currently written so that they are reading the input data from this Git repository itself. So for convenience, we have pushed 2 sample traces here so that you don't need to start creating your own traces, but you can just play with these sample traces initially. And let's try to run some of these. We can start with plant UML. So I think in last SprintDemo that was mentioned by someone that maybe you should look into plant UML because that's a popular format that has many nice ways how you can visualize your diagrams. So we created a script that allows you to translate one of these art trace files into plant UML format. There are already launch configurations available for all of these. So if you just go to run debug, you can select here plant UML and run it. And currently the output will be printed directly here in the debug console. So you just copy all, and then you can go to the plant UML web server web page and paste it here. And you need to delete the first line because that is the application itself. It's not output from the application. And then you get the sequence diagram that actually looks very similar to what you can get in the sequence diagram viewer inside Code RealTime. But for example, here you have more a richer notation than what JL sequence diagram gives you. You can use colors, you can use lots of symbols. There are many possibilities in this web service. Then if we look at some other example here, we can take, for example, a very simple script that finds the top most expensive transitions of an application, basically computing the difference between those two timestamps I mentioned before. So if we go to message handling performance and run that, then it will again print output here. So it starts by sorting the messages according to the difference between those timestamps, and then it just captures the top 5 most expensive ones. And here you see that the first one here took, 9.5 milliseconds. Actually, those 3 here come from the startup of the application. So the fourth one here is actually the first transition that is coming from the user application or user model. And we see it took 2.6 milliseconds. So this is a simple way to measure performance. Of course, in a more realistic scenario, you would most likely want input from more than one execution to draw any conclusions. So you could run this script with some wrapper script that takes multiple trace files as input. Another sample is this sort on receive time. So by default, we are sorting the messages on the time when the messages have been handled. And that is often good, but sometimes you instead would like to see them in the order in which they were received instead. So if we run this script, we'll see that it will take an art trace file as input, and it will emit another art trace file as output. But here it has sorted so that all messages come according to this timestamp instead of this timestamps, which typically gives, instead of getting bottom-up initialization for synchronous messages, you get top-down, which maybe is more like how you think about how a synchronous invocation looks like. And last script here is something that is still work in progress. So Google has, which you may know, a nice trace event format, which, by the way, is clearly documented here on this page here. And that is a very popular trace format for performance analysis that is, for example, Google uses for its Chrome browser and many other applications. And so the goal with this script is to translate an art trace file into the Google trace event format. Here I've used a very simple application because currently the limitation is that we only support single-threaded applications. So it's still, like I said, work in progress. But if we take this, which is basically a simple hello world sample where I have 3 nested capsule parts that get initialized when application starts up. And if I run that, we will get in the output folder a JSON file which adheres to this Google trace event format. I can copy that, and then I can open a JSON file and I can paste it here. And to make it a little bit more visible, I can also format the document. And this format basically, for duration events, which is things that happen on a single thread, they use two phases. So phase B stands for begin, and every begin phase is then ended with a corresponding end phase here. And the timestamp here are given in microseconds. And you see, like I said, we are currently hard-coding the process ID and the thread ID to 1 because we don't support, we don't have information yet in our trace format about threads, which is why we cannot yet generate this thread information. So now if we take this, we'll save this file, and I will switch to this web browser. And maybe you didn't know it, but if you just type tracing in your Chrome browser, you get to this built-in trace viewer that Google gives you for free. And here you can click this load button, and you can select the JSON file that I just saved. And then it will load this trace into this web browser. Then you can press the W key. You see here there is something happening at 0 milliseconds. This is the application startup. Then there was a 2-second timer where nothing happened, and then there was a message here when that timer timed out at 2 seconds. So if we want to look at what happens, we can press the W key to zoom in to see more details on what happened. So here there was initialization, which is actually coming from the target RTS when that starts up. And then there was a timeout telling that now basically the application is ready to start running. And these 3 initialized calls here, they come from the initialization of these nested capsule parts that I mentioned. I had 3 levels in my Hello World sample. Then you can press S key to zoom out again and go back to see if we come here to the 2-second and zoom in here, we can see the other message that is sent, the timeout message for the Hello World. And there are lots of features here in this trace editor that I must admit I haven't yet explored. You can look at statistics and metrics and all sorts of details to track different interesting criteria, performance criteria of your application. There is a more modern version also of this called Perfetto, which is another web service. It works in a very similar way. Most keyboard shortcuts are even the same. So if you open it here, you get a very similar trace view here. You see something happens here, and then you have, at the end here, you have the 2-second timeout. And similar way, you can zoom in here to get a similar view of this trace. I haven't compared this in detail. They claim that this new version is able to handle much bigger trace file and is in general more feature rich. But for the simple examples I've used so far, I haven't really noticed any difference between these two trace tools.